Welcome to the KWARXS demo. In this demo, we'll be showcasing the core functionalities of the KWARXS protocol implemented in Atlas, in Haskell, and we are going to be submitting this demo as proof of achievement for milestone 1 and milestone 2. So we will be doing building real transactions and submitting them on the preview testnet, which is currently running Conway, therefore proving a milestone 2 as well as milestone 1. So for this, we have two users set up here in this playground. One of them is the operator, and the other one is the client. The operator will be in charge of creating a reward pool where it will initially be created with a set amount of reward denominated in particular profit assets chosen by the operator, and the client will be able to interact with that pool, specifically withdraw portion of that reward by burning special NFTs that are chosen by the operator during the creation of the pool. So if we go to some blockchain viewer, in this case I'm using Cardano Scan, you'll see that this is the operator address and this is the client address in this example. So first things first, what we'll do as the operator will be creating a pool. So we have this Atlas function implemented in our code base which creates a pool. It takes some information about what sort of rewards the pool is going to have, what sort of special NFTs the pool needs to burn, or sorry, the client can burn in the witness of the pool to be able to withdraw rewards and stuff like that. And these are always predetermined by the operator, and that's how these pools are identified. So I already have some parameters set up here. Create pool parameters, which essentially identify the pool based on which reward assets it will support and which special NFTs can be burned to withdraw said rewards. Here we're using specific currency symbol of a very special NFT that will be used in the real protocol, and we will be minting one of those NFTs soon, and there's some more information about how many of those special NFTs will be supported by this pool, and a bit more information about the token name of the special NFT. Specifically, it has a counter at the very end, and the counter is incremented every time it's burned, and this specific pool supports the ones where the counter reads 1. And of course there's also an identifying asset that is used to identify the pool itself, and this is just the token name of that asset, but yeah, this is just a token name that the operator will choose. So we will be using the operator to essentially create a pool, and I have this code right here already, and again, all the parameters to create pool will be predetermined by the operator to uniquely identify a pool. And so let's go on ahead and try and build this. Okay, so that says that we were able to submit a transaction, and we will look this up in the Blockchain Explorer that creates the pool. And this is the asset that uniquely identifies the type of pool that we just created. And I will be storing this asset, okay, because it'll help us identify the pool that we just created later on. Now let's go on ahead and see if we can find this transaction. It usually takes a bit of time for the transaction to show up, so we will wait for it to show up for a bit. Okay, looks like that transaction showed up, and here you'll notice that we have indeed sent a pool into this pool validator address, which contains the unique identifying pool NFT and of course all the reward assets that we have in there. And specifically for this pool, you will notice that we chose some test assets, reward coin A, reward coin B, but we also chose Loveless as one of its reward assets. Now, of course, if you can look into more details of this transaction, how the pool NFT was minted, that's its own NFT policy that we also have implemented as part of this protocol, and of course the contract address and code and all of that. Now, what we will now be doing is making sure that indeed this pool does indeed exist, and for that we'll be using this another Atlas function that we have implemented called getRewardPools, which just needs the pub key hashes of the operators that were used to or who built the pool, and of course the uniquely identifying pool NFT. And actually let me just eval that, and that will actually give us a list of all the pools that match said criteria. Now, one of these is actually something I created before while testing, and this is actually the one that we just made. And you can verify that because if you see here, this is the transaction ID that we just looked up, and indeed it is right here. These are two of the same. So we will just go on ahead and get the second one. Oh, actually, I will have to store this somewhere. So, pools, and the specific pool that we're interested in is, of course, the second one. So, we'll just get that, and let's just verify that that is indeed the pool. Now, to interact with this pool, we can withdraw a portion of the reward that is there by burning one of the special NFTs. Now, this is how a client, for example, can interact with one of these pools. But of course, firstly, what the client needs is one of these special NFTs. And how we do that is we have another Atlas function written here, which is buy NFT, which is actually for this special NFT that we just associated with the pool. Now, buy NFT specifically takes a buy NFT params, which essentially just kind of identifies the NFT we're trying to buy. Of course, the operator that needs to be paid as part of a commission for buying that NFT, and a bunch of other things that identify the unique special NFT name. These are all predetermined as well, and these are the NFTs that will be listed up for sale that the users can buy. And let's try to buy one using our user here, in fact, as user client. And so the second one is actually just needs to be the operator address, because we do need the operator to sign on this kind of NFT minting, because otherwise the contract will actually fail. So, and we have another parameter, which is essentially we just have to say that we are sending it to this client, and we have to say the name, which is here, and we already have chosen a name. Again, these are going to be queried from a database and then listed up for sale. So these names are going to be predetermined, and the name has to match a specific criteria to be able to support being burned to withdraw reward. So it has to be very special NFTs. So let's just evaluate that. Okay, so here we have the transaction ID of the transaction where the user bought this NFT. We can of course look it up once again. Okay, looks like it finally showed up. Took a bit longer than usual, but here we can see that indeed we did use the special contract we have for this special token, and we did indeed mint this special token. And indeed, as we can see, there is this counter, the last bit of the token name depicting the counter, it is indeed 1, which is supported by this specific pool. Now let's go on ahead, and I did also go ahead and check that indeed the client does have this in their wallet. Let's go on ahead and try and interact with the pool by withdrawing some reward. So this is the pool that we just created that we will be withdrawing some rewards from. And actually we were able to find it in this transaction here, I believe. Yes, so this pool actually has this amount of assets, so 300 reward coin A and B, and a certain amount of Loveless. Of course, a portion of that is min ADA, but there's a significant amount that is actually just the reward. So what we'll be doing here is using this function called withdraw reward, which first off will take the NFT minting policy ID, or actually just the NFT minting policy itself, of the special NFT, and this we can obtain by actually just doing this. I have these utility functions set up to give us the special NFT, and of course it needs the operator pub key hashes, and I also have this right here. Okay, so let's just make sure we know what the parameters are here. So these are the parameters we'll be using. This just says that we're going to be withdrawing from this pool, that this is the pool that we just created, and it also identifies which NFTs will be burning. So this is just this part is just identifying which NFT in our wallet we're trying to burn to withdraw a certain amount of reward. And in this case, we're just burning 1, so we'll be withdrawing 1 special NFT's portion of rewards. So let's go on ahead and evaluate this as client. So if we evaluate that, and there we go, we have, I believe, a transaction ID of a successful transaction, and indeed we do have it reflected already in this interface here, that yes, the user did gain some Loveless, these reward assets, specifically 100 of each of these, because we burned 1 special NFT, and there were 300, and the pool supported a maximum of 3 burns, so we got 1/3 of it. And we also lost the NFT that we had, but we reminted another one that was essentially just the same NFT, but the counter has been increased. So this remint action is a different sort of redeemer of this minting policy that we have here. And so let's actually go on ahead and maybe we can try and find this. Maybe we can try and find this transaction on the chain now. Okay, so here it is. Here is the transaction, and this is the transaction hash that we saw earlier. And indeed, it essentially interacts with the pool that we made to withdraw a certain amount of rewards, and by burning this special NFT. And that is the core functionality and core flow of the KWARXS protocol. In summary, an operator or several operators create a pool that have this association with special NFTs. One of these special NFTs we do provide a minting policy for, and a user is then able to buy these special NFTs to be able to withdraw portions of rewards deposited in these pools. And that concludes our demo for showcasing our milestone 1 and milestone 2 completion of KWARXS. We hope that showcases every functionality that was promised into the proposal, and if there is any doubts, please go on ahead and let us know.